Hello everyone, I'm Agus Gunawan. We'll talk in this video about our recent work, modernizing old photos using multiple references via photorealistic style transfer. This is our work with Suye Kim, Hyeonjun Sim, Jae-Ho and Munchurl Kim. All photos in the wild contain mixed degradations such as structured and unstructured degradations and also unique artifacts. To make these photos look like modern photos, previous work mainly focused on degradation restoration and modernization by implicit enhancement. However, enhancing the color is inadequate to ensure all photos look modern since the overall look and style still remain similar to those of old photos. This problem motivates us to modernize all photos by changing their styles and enhancing them. To achieve this goal, we propose a novel unified framework that leverages multiple modern photos as references to guide the modernization process. As a result, our framework can modernize all photos better than the SOTA old photo restoration method, even without using any old photos during training. Our framework is inspired by photorealistic style transfer, PST, which has shown its universal ability to perform style transfer for any photos without retraining to predefined styles. However, three main problems are hindering us from using PST directly for the modernization task. First, previous PST work can only use a single reference, where it's difficult to find a single modern photo as a reference that can well match the whole semantics of the natural old photo. Second, previous PST work requires additional semantic segmentation masks to perform local style transfer, where unreliable segmentation masks can produce unnatural PST results. Third, previous PST work can produce unnatural global style transfer and cannot perform an enhancement. To solve these issues, in this work, we propose a multiple reference-based old photo modernization framework that consists of two main parts. The first part is MROPM-Net, which consists of two subnetworks, a single stylization subnet that can perform both global and local PST without any semantic segmentation mask, and a merging refinement subnet that merges multiple stylization results and further refines the merging results. The second part is a novel training strategy that generates synthetic training data to train our network, enabling the network to utilize multiple references for modernization. Let's dive into the details of our network. In the first step, we perform style transfer from each modern photo reference to old photo input, resulting in two, in this case, different stylization features and correlation matrices by utilizing a shared single stylization subnet. Given features extracted from the pre-trained backbone PST network, the key idea of our single stylization subnet is to predict style code to perform both global and local PST. First, we compute the local style code through local filter operation and the global style code through channel-wise computation. Then, the local style code is aligned by using non-local attention between the features of old and modern photos. The local and global style codes are then fused through channel-wise concatenation. Then, we perform style transfer by using adaptive instance normalization to modulate the decoder's features of the old photo. In the next step, we use the merging refinement subnet to merge multiple stylized features and refine the merging results to produce the modernized version of the old photo. Specifically, we boost or dampen each stylized feature depending on the correlation matrix by using spatial attention, which then will be summed and refined by using UNet. The next core idea of our work is a synthetic data generation scheme, since there is no ground truth for old photo modernization tasks. To generate the data, we need a dataset that has a dense semantic segmentation mask for each image. The main idea of our data generation scheme is to use two different transformations, which are style variant and invariant transformations, where the invariantness property depends on whether the transformation alters the style code of any semantic region. Given an image that will be the ground truth and semantic segmentation mask, we split the label of the semantic segmentation mask into two unique sets to make binary masks. Then we multiply the binary mask and the ground truth image. To make the synthetic reference, we apply SIT and fill the unmasked region with a random image. Meanwhile, we apply SVT to make the synthetic orthophoto. For the benchmark, we propose a cultural heritage dataset consisting of gold color photos produced in the 20th century. Different from previous public orthophotos dataset, which mainly consists of portrait photos, our dataset contains indoor and outdoor scenes of cultural heritage. Since our task uses references, we further collect modern photos as references by crawling images from the internet. First, we evaluate the method using synthetic data. As can be seen, our method achieves the best PSNR and LP-IPS and comparable SSIM score, which shows that the method can effectively utilize the references to jointly stylize and enhance the synthetically degraded images while preserving the structure. The second evaluation is a real-world photos evaluation by using no reference metrics. Our method outperforms other baselines significantly using a single reference and further improves the performance by using multiple references. Additionally, we conduct a user study to compare the modernization results, where our method outperforms other baselines with a 56.37% chance selected as the best method. To study the effectiveness of our network, we first conduct an ablation study of the single stylization subnet on real-world photos. The subnet fails to accurately transfer the local styles of objects when the alignment module is removed. Adding the fusion module further improves the performance, resulting in smoother stylization both locally and globally. Next, we study the effectiveness of the merging refinement subnet both on real-world photos and synthetic degraded photos. Both real and synthetic data evaluation shows that this subnet is able to select relevant regions from multiple references to transfer their styles to the corresponding region in the input. Qualitatively, our method is generally able to utilize multiple modern photo references to achieve better modernization, even though it has not been trained with any old photos. The last row of the figure also shows the robustness of our method when faced with unrelated references. In addition, we also show the results for old photos in the wild, where our method can match the corresponding semantic regions between the old photo and multiple references, even when the viewpoint and scale are different. Our method can also be used for semantic photorealistic style transfer. Here are some results of the user study with varying percentages of user voting. Generally, our method compares favorably against the baselines. Please visit our project webpage for the code and dataset. We will present our work at CVPR 2023 on Wednesday afternoon with poster number 11.